I'm going to tell you something that will shatter your understanding of time. The past is not fixed. What happened yesterday is not written in stone. And I can prove this with one of the strangest experiments in quantum mechanics. The past can change, and the future is what changes it. My name is Roger Penrose. I've spent 60 years thinking about the nature of time, causality, and the structure of reality. And I'm going to show you why everything you believe about the past is wrong. The past is not behind you. The past is in superposition, and what you do now, right now, in this moment, determines what actually happened back then. Let me start with a simple question. When did the past happen? You'd say, in the past. Obviously, that's what past means. But quantum mechanics says something different. The past happened when you observed it, not when the event occurred, when you measured it, and if you haven't measured it yet, if you haven't collapsed the quantum state, then the past hasn't happened, not in any definite sense. All possible past exist in superposition, waiting for you to choose one. This sounds like philosophy. It's not. It's experimental fact. Let me show you the experiment that proves it. It's called the delayed choice quantum eraser, and it's one of the most disturbing results in all of physics. Start with the double slit experiment. You know this one. Fire photons one at a time at a screen with two slits. Each photon goes through both slits simultaneously. It's a wave interfering with itself, creating an interference pattern on the detector. But if you measure which slit the photon went through, the interference disappears. Now it's a particle. It went through one slit or the other, not both. This is wave-particle duality. Observation changes the outcome. Everyone knows this. But here's the twist. What if you decide whether to measure which slit after the photon has already gone through? Common sense says it shouldn't matter. The photon already went through the slits. It either went through both, wave, or one particle. The past is fixed. Your later choice can't change what already happened. But quantum mechanics says, watch this. In the delayed choice experiment, you let the photon pass through the slits. It's already on its way to the detector. The past, whether it went through one slit or both, should already be determined. But then, before it hits the final detector, you make a choice. You insert a measurement device that determines which slit it came from, or you don't. If you measure which slit, no interference. The photon was a particle. It went through one slit. If you don't measure, you get interference. The photon was a wave. It went through both. Your choice, made after the photon passed the slits, determines what the photon was when it went through. The future choice changes the past event. Now you might object. Maybe the photon knows in advance what you're going to do. Maybe it anticipates your choice and behaves accordingly. That's when the quantum eraser comes in. In the quantum eraser version, you set up the experiment so that which path information is recorded. Say, in the polarization of the photon. This destroys the interference pattern. The photon went through one slit or the other. But here's the trick. After the photon is already detected, you can choose to erase the which path information. You perform a measurement on a correlated photon that retroactively makes it impossible to know which slit the first photon went through. And when you do this, when you erase the information after the first photon already hit the detector, the interference pattern reappears in the subset of photons where the information was erased. Let me repeat that. The photon hits the detector. Then you erase which path information, and retroactively, the photon interferes with itself. The past changes. What actually happened at the slits depends on what you do later, after the photon is already detected. This is not interpretation. This is experimental fact. These experiments have been done. The results are clear. The past is not fixed until the future collapses it. Now, how do we make sense of this? The standard Copenhagen interpretation says, don't ask what really happened. Just use the math to predict measurement outcomes. Shut up and calculate. But I've never found this satisfying. If the math says the future affects the past, we need to understand what that means. The block universe interpretation, which I find more compelling, says this: all of time exists. Past, present, future are equally real. They're all out there in the four-dimensional space-time manifold. But which events in the past are definite, which actually occurred, depends on future measurements. The past exists in superposition, multiple potential histories, all real, until the future collapses it into one definite history. From the photon's perspective, it doesn't go through one slit or go through both slits when it passes the barrier. It exists in a superposition of both possibilities. That superposition propagates forward in time. When you measure which slit, you collapse the superposition into one slit. When you don't measure, the superposition remains and you see interference. The past state of the photon, which slit it went through, is not determined by what happened when it passed the slits. It's determined by what you measure later. This is retrocausality, the future influencing the past. But it's not time travel. It's not violating causality in the usual sense. It's recognizing that in a block universe with quantum superposition, the past is not definite until the future makes it so. Think of it this way: the photon's entire history, from emission through the slits to detection, is one quantum process. The measurement at the end collapses the entire history into one definite sequence of events. Before the measurement, the history is in superposition. The photon went through slit A. The photon went through slit B. The photon went through both, all simultaneously real, none more actual than the others. The measurement doesn't just tell you what happened, it makes what happened definite. Now let me take this further, because if the delayed choice experiment shows that the future can determine the past for a photon, what about for larger systems? What about for the universe? In cosmology, we observe the cosmic microwave background, light from 380,000 years after the Big Bang, reaching us now after 13.8 billion years of travel. When that light was emitted, was the universe in a definite quantum state? Or was it in superposition? If it was in superposition, then the quantum state of the early universe is not determined by what happened 13.8 billion years ago. It's determined by what we measure now. Every observation we make of the CMB, of distant galaxies, of primordial gravitational waves, we're collapsing the quantum state of the early universe. We're making the past definite. Before we measured it, the early universe existed in a superposition of possible states. Our measurements now select which of those states actually occurred. The history of the cosmos is being written now, by us, by our observations. This is not mysticism. This is the straightforward consequence of taking quantum mechanics seriously at cosmological scales. John Archibald Wheeler, one of the great physicists of the 20th century, my colleague and friend, proposed what he called the participatory universe, the idea that observers play a role in bringing the universe into definite existence. He didn't mean that consciousness creates reality in some magical sense. He meant that quantum measurement, the physical process of observation, collapses superpositions and makes events definite. And in a quantum universe, if the past is in superposition until measured, then observers participating in measurements are participating in making the past real. Wheeler illustrated this with a diagram. The universe begins in quantum superposition. As it evolves, it remains in superposition until measurements occur. Those measurements, made by observers, by physical systems, by anything capable of collapsing wave functions, determine which history becomes actual. The past is not a fixed foundation on which the present rests. The past is fluid, quantum, indefinite, and the present is constantly reaching back, collapsing it, making it definite. Now, I must be careful here. This does not mean you can change the past in any arbitrary way. You can't go back and prevent your parents from meeting. You can't rewrite history to make yourself king of England. The past that gets determined by future measurements must be consistent with all other observations. The quantum state collapses in a way that preserves logical consistency. But within the constraints of consistency, the past is genuinely undetermined until observed. Think of it like a quantum detective story. A crime occurred. But the details, who did it, how, when, are in superposition. Multiple versions of the crime coexist. When you gather evidence, you're making measurements. Each measurement collapses part of the superposition. Eventually, enough measurements accumulate that one version of the crime becomes definite. But before you investigated, all versions were equally real. The past crime was in superposition. This is how quantum mechanics treats all events. Until measured, they're in superposition. Measurement makes them definite. And if the measurement happens in the future, it retroactively makes the past definite. Now, how does this fit with my own work on objective reduction? In my OR theory, I propose that quantum wave functions collapse not when a conscious observer looks, but when the superposition reaches a threshold of gravitational self-energy. The collapse is objective, driven by physics, not observation. But even in objective reduction, there's a time at which collapse occurs, and before that time, the system is in superposition. For small quantum systems, photons, electrons, the gravitational threshold is never reached unless they interact with something macroscopic, so their superpositions can persist for a long time until a measurement, a macroscopic interaction, forces collapse. This means the delayed choice experiment still works in objective reduction. The photon state remains in superposition as it travels through the apparatus. Only when it interacts with the macroscopic detector does collapse occur, or when you perform the later measurement that erases which path information. The gravitational threshold is what makes collapse objective, not observer-dependent. But the collapse still occurs at a specific time, and until that time, the past is indefinite. So even in my framework, the future determines the past. The difference is that future means when gravitational threshold is reached, not when a conscious observer looks. But the conclusion is the same. The past is not fixed until physics makes it fixed, and when that happens can be later than when the event occurred. Let me address the philosophical implications. If the past can change, or more precisely, if the past is undetermined until the future collapses it, what does this mean for free will, for causality, for history? First, causality. The past influencing the future is standard causality. But can the future influence the past? In a block universe, causality is about which events are in the light cone of which other events. An event A can influence event B if B is in A's future light cone. Retrocausality, future influencing past, would seem to require information traveling faster than light, backwards in time. But quantum entanglement allows correlations without information transfer. The delayed choice experiment creates correlations between the later measurement and the earlier photon state. But no information actually travels backward. So retrocausality in quantum mechanics is not the same as time travel. It's correlation across time, mediated by the quantum state. Second, free will. If the past is undetermined until measured, does that mean we have retroactive free will? Can our choices now change what happened yesterday? In a limited sense, yes. If an event in the past is quantum mechanically undetermined, if no measurement has collapsed it, then a measurement you make now will determine what actually happened. But for macroscopic events, like whether you ate breakfast yesterday, those are already collapsed. Decoherence and gravitational thresholds make classical history definite very quickly, so you can't retroactively choose whether you ate breakfast. But for quantum events in your past that haven't been measured, your future measurements do determine their outcomes. Third, history. If the past is in superposition until observed, what does that mean for historical events? For macroscopic history, World War II, the French Revolution, the building of the pyramids, these are already definite. Too many measurements, too much decoherence, too much gravitational collapse. But for quantum aspects of history, the exact microstate of Napoleon's brain when he decided to invade Russia, the precise configuration of photons illuminating the pyramids. Those might still be in superposition, not that we could ever measure them. Decoherence has spread those quantum states into the environment, making them effectively lost. But in principle, if you could perform a measurement that retroactively revealed quantum information from the past, you would be collapsing a superposition that has persisted for centuries. The classical past is fixed. The quantum past is not. Now, the ultimate question: if observations in the present determine the past, and if conscious beings make observations, do conscious beings create history? Wheeler flirted with this idea. He suggested that the universe might be participatory at a deep level, that observers are necessary to make the cosmos definite. I'm more cautious. Observations collapse wave functions, yes. But observations don't require consciousness. Any macroscopic interaction, any system reaching the gravitational threshold for objective reduction, can collapse a wave function. Consciousness is one way to amplify quantum events to macroscopic scales, through neurons, through measurement devices we build. But it's not the only way. So conscious beings do participate in making history definite, in the sense that we make measurements that collapse quantum states. But so does everything else that interacts at macroscopic scales. The past is determined by physics, not by consciousness specifically. Still, there's something profound about conscious observers making measurements of cosmological quantum states. When we observe the CMB, we're collapsing the quantum state of the early universe. We're making 13.8 billion years of cosmic history definite. We're writing the past, not arbitrarily, within the constraints of consistency, but genuinely. The past wasn't fully determined until we looked. And that makes us participants in cosmic history in a way that's deeper than just we live in the present and study the past. We're helping to create the past retroactively through our observations. This is the participatory universe, not consciousness creating reality out of nothing, but observation, physical measurement, making reality definite. Let me bring this to a close with the most disturbing implication. If the past is in superposition until measured, then there are events in your past, quantum events, microscopic details that are still undetermined. Your brain is a quantum system, at least at the level of individual neurons, and possibly at deeper levels, microtubules, ion channels. Quantum states in your brain's past might still be in superposition, which means your memories might not be fully determined. The exact neural states that encoded your memories might still be in superposition, waiting for a future measurement to collapse them. You think you remember what happened yesterday, but if the quantum details of that memory are still in superposition, then what actually happened in your brain yesterday is being determined now, as you remember it. The past you remember is being created by your act of remembering. This is not to say your memories are false. They are constrained by consistency, by all the other measurements and interactions that have occurred. But the quantum details, the fine structure of the past, might genuinely be undetermined until you access the memory. And that means the past in your brain is not a fixed recording. It's a quantum state, collapsing into definiteness as you remember it. This is deeply strange. But it's what quantum mechanics requires if we take it seriously at the level of the brain. So here's where we are. The past is not fixed. It's in quantum superposition. Future measurements collapse the superposition, making the past definite. This is not time travel. It's not violating causality. It's recognizing that in a quantum universe with a block space-time structure, the past is fluid until observation makes it concrete. Every observation you make is a choice about what past becomes real. Not an arbitrary choice. You can't violate consistency, but a genuine choice nonetheless. The past is not behind you, finished and immutable. The past is beneath you, supporting you, but still quantum, still in superposition in its fine details. And every moment you live, every observation you make, every memory you access, you're reaching back, collapsing those superpositions, writing history. Not the history of nations and wars, that's already definite, but the quantum history of the universe, the microstate of the cosmos, the fine details of what actually occurred. Those are yours to determine, not by will, but by measurement, by living, by observing. The delayed choice quantum eraser proves this. Wheeler's participatory universe explains it. And the block universe with quantum superposition makes it inevitable. The past can change, not in gross macroscopic ways, but in quantum details, in the fine structure of what actually happened. And the future, your future, our collective future, is what determines it. So when you think about yesterday, remember, you're not just recalling the past, you're collapsing it, making it definite, writing it into the permanent record of what actually occurred. The past is not fixed. It's waiting for you to decide what it was. And that decision happens now, in the present, where the future reaches back and makes the past real.